Alright guys, I'm inside the boat now. These are my jumper cables I use to test the motor on the hydraulic pump. And what you do is you grab yourself really thick 10 gauge or better wire, because it's 30 some amps. I tin the end of this at just soldering it with some flux and electric grade solder, electronics grade. These are just meter leads, fluke. Just plug it on the end of this wire right here, and it'll end up looking just like the red wire, and it just pops right off. But I did solder these clips on. You just clip negative, blue to black, negative on the battery, red to positive. Make sure they never touch, or else they will arc and weld themselves together. Batteries have a lot of current. So anyhow, there's your battery bank. I got hooked up to this trickle charger all winter long, so these batteries are really old. They're I bought the boat 2 years ago, and they're still going strong because this trickle charger starts up strong. Haven't had started in 2 years. Started right up this week, all thanks to this trickle charger. And I left the selector switch on all so that the battery cross charged both batteries. You see the way I got that set up: red on one battery, black on the other battery, and yeah, they're both fully charged. So anyhow, you take those jumper cables that I made. If you're testing out your trim motor, you come back here. Got myself a little pointer, and yeah, these little struts. Had to take these off the sun deck so that I could get back here, back in the back of the boat, the stern. So what I did, you disconnect this right here, and then you hook up, red to one lead, black to the other lead. Your motor should turn on. Mine did not. Therefore, I knew the motor was bad. So the easy thing to do is I took out these two screws right there and there, the through bolts, and then this whole motor just comes right off of this pump assembly right here, and you take it down in the basement and you work on it. So what I did is I took off this bottom cover, polished it up, got rid of all the corrosion, put some oil drops in the bearing cup. It's a brass bearing down there. This is called the field, so you got some ceramic magnets on there that are very strong, very clean, easy to wipe off with a paper towel. So don't bang on it with a hammer, because you could knock those loose. And then the top plate, this is just the bearing housing, but it's also got a circuit board in it where the brushes are housed. My brushes were still good, but the problem was up here. So that cup, I cleaned it up, threw some oil in the cup, and then I threw some synthetic bearing grease in there. Same on the bottom. And before I slapped it all back together, there's an O-ring right here between this case and this top cover, same with the bottom. So I just ran my finger with a finger full of plumber's grease that you get at Home Depot in the plumbing section, and that just keeps the seal pliable, and it keeps it waterproof, so it'll help keep the moisture out. And also, when I put these bolts back in, I polish them up on the bench grinder. I polished up the rotor that's inside here, the part that spins inside of the magnetic field whenever you apply power, and that's what drives the hydraulic pump. But so I polish it up. I polish up this end of the bearing where it seats into the bearing. I polish up the other end where it goes through the bearing. I applied a heavy dose of synthetic grease, which is this Valvoline grease that I've had for probably a decade or more. But I fix a little bit of everything, so good grease comes in handy. Then when I got down to it, I took this apart. I cleaned these up with I went to Home Depot for like $8. I bought some WD-40 contact cleaner. I sprayed the contacts inside the female, inside the male. I took out these relays. You got your up and down relay, and those just easily rock out of the sockets. They're not clipped in, but you just rock them out. Cleaned them out with the contact cleaner. Then I cleaned the contacts on the relay itself, and then down inside of the female connector down here in the housing. This is all mounted on a vibration kind of base, so these relays can move around easy when the boat's shimmying through the water, taking on waves. Anyhow, squirted some dielectric grease down in each one of the 5 slots for the forward relay and the aft relay. Slapped the relays back in, plugged up my power, and tested it with the helm switch, and the trim tilt motor worked perfect. So the motor went up and down. I was able to get my motor down, check the fluid level in the Outdrive. It was perfect. There was no foam. It was still crystal clear, and everything's great. This reservoir The oil's good to go. I've got a new pump. It was about 222 bucks on Amazon. Takes about a week to get here, even though it's prime. It's coming from someplace, but something that's noteworthy is that this is an original Volvo Penta, but that SAE J1171, what that signifies is any part that has that SAE on it signifies that it's a marine grade component. So you'll have that on your starters, your electric motors for your hydraulic pump, and some other components within the engine, probably your alternator, etc., etc. Things that can withstand high humidity, moisture content, such like, things of that nature. So anyhow, that's my boat. It's a 2002 Crownline SX-M Outdrive, single propeller, and with a 5.7 GL engine, carbureted. And the other thing I want to tell you guys about is what I did about 3 years ago when I filled the tank up. It's a 55-gallon tank in this boat. I dumped the whole thing of stable in there, and I dumped in, good God, I don't know, you'd have to read the directions, but I dumped in the appropriate amount of Lucas carburetor and injector cleaner that you buy at Walmart. And this gas sat for 2 years, over 2 years, and this engine started right up and idles like a freaking baby. Just purrs like a kitten. So you want to do that. And you make sure you always hook up your water pump, your water muffs out on the Outdrive. You never start these engines dry. There's a little impeller in the bottom of the water pump that is rubber, and if it doesn't have water as a lubricant, it will burn out immediately, and then your engine will overheat. And that's just no good for anybody in the middle of the ocean or the lake, river, wherever you boat at. So those are some good hints that I have, some experiences that I've gained. I was in the Navy, electronics by trade, so I think I have a little bit of a clue what I'm talking about. But yeah, this motor, I was kind of hesitant. That's why I bought the new one. I was like, well, maybe the pump's bad too. But when I took the motor apart and saw what was wrong with it, that it was just seized up because of rust, it was a pretty darn easy fix, and it was free. So it just cost me a little bit of time. Another thing I want to point out before I conclude the video is on the top of these through bolts, they bolt down here to the pump reservoir, or the reservoir which goes to this pump assembly. This is just the motor that drives the pump, but I put some grease up here. There's O-rings on the top of this, so there's a flat washer O-ring, then it goes to touches the case, and on the bottom there's two rubber O-rings that kind of hold the bolts in place, and then the bolts just bolt right down here to this on the left and the right of this pump housing. So it's a really easy fix, guys, and it'll save you tons of money. And then if you got to replace your motors are like 70 bucks, and the whole pump now is going for about 225 bucks, roughly. So there you go. And this little gadget over here at your fuse assembly, just pop it open. It's like any automotive fuse. It's a blade fuse, 10 amp bus fuse. And you can see the heavy duty wires down in the bottom of the relay assembly right here. That just shows you that there's a lot of current that goes here. So the way that the system works is the helm switch are little control wires, and they just carry a little signal back here. Causes these relays to up relay, down relay to fire, and whenever they fire, they close, and then they let the voltage and the current, which is very massive, like 30 amps, goes through these wires and causes the engine to turn. And all the relays do is they reverse polarity. So you got positive here, ground here, motor goes one direction, say clockwise, the engine goes up, and then the relay fires. When you switch the helm switch to the down position, this becomes positive, this becomes negative, motor goes in the reverse position or direction, and the true motor goes down. So hopefully I said that right. Well, I hope that helps out, guys. Good luck, and happy boating. Hoo-yah.